So, welcome. We thought it would be appropriate today to have a bit of a panel session, so we've invited these gentlemen to answer questions. Before I ask for questions from the audience, though, I'm going to ask them each to introduce themselves. So, starting with this fine-looking young man here.
Hello, my name is Grant Likely. I am a Senior Technical Director at ARM, working in the open source software system architecture team. And prior to that, I was a kernel engineer, and I worked for you.
Yeah, and he still talks to me.
I still talk to you.
I'm Larry Wickelius. I work for Marvell. I'm responsible for our partner engagements and ecosystem enablement on the server part of Marvell with ThunderX2.
Great. I'm Jacob Smith. I'm a co-founder and the chief marketing officer for Packet. And so I run our revenue marketing, our community partnerships, and a good part of our strategic alliance portfolio.
Okay, thanks guys, and thanks for agreeing to come on a panel in the middle of this week. So the first question I'd like each of you to answer in turn is, arm on arm is a pretty, it's kind of a phrase that we knock around and maybe we don't entirely mean the same thing or whatever. What does arm on arm mean to you?
So for me, ARM on ARM is very much, it's very much completeness of ARM being a real platform that hits all the areas of the ecosystem. I mean, my background is embedded. I grew up doing embedded system development, an awful lot of ARM platforms, and there's a lot of things that we did in embedded that was different from what was going on in the PC world. Firmware looked different. You do a lot of cross development, and it's things that you're running on your platform don't run quite the same way on your PC. So going to ARM on ARM means that we're getting that level of robustness and level of testing and level of integration for us as developers, that the things that I'm experimenting with and testing on my desktop, on my workstation, means that it also, I can run it on the server, I can run it on the embedded, and I've got all the same set of tools in all of those places.
Okay, thanks. Thanks.
So from my perspective, especially with a focus on server, it's really more that deployment side and being able to run solutions and applications in an ARM environment just as I would on any other architecture. So I used an example this morning in my presentation around EDA with Cadence. So a fundamental part of our silicon development is running EDA tools. Historically, today, generally, you're going to see that running on x86 systems, but now with ThunderX2 and other options in the ARM space, we can do that on an ARM platform. So for a company like ours, where we're delivering ARM-based silicon, I'd much rather run my tools on an ARM platform. And I think many other of the partners within Linaro and the conference this week would look at that similarly. So from that perspective, for us, ARM on ARM is much more that deployment and solution consumption side.
Great.
Yeah, I come from Larry's world as well. I actually use the word, the first word that comes to my head is dogfooding. In a software world, you think about eating your own dog food, and it's that sort of like swagger that says you're going to use your product before you sell your product or as you sell your product. So I kind of relate to what Larry is saying in terms of the internal use case. But for me, like the obvious things are even like, what's your website running on? You know, what's IT doing for their email server? It's just that sort of buy-in on the product that you're asking other people to buy.
From actually using it.
Yeah.
I get what you're saying. Okay, is there anyone in the audience who'd like to ask a question at this point? These gentlemen? Come on, you must have a question.
Steve's got a question.
So, go on then. Is the Packet.net or Packet.com website all running on ARM?
So Packet.com is not. Our worksonarm.com is. Yeah.
So what are you missing? What's stopping you from running it all on ARM?
Yeah, sure. So nothing really. Intent, yeah. Plus, we have lots of friends across architectures, so we have a little bit of that. But to be honest, it would be, it was very easy to do Works on ARM because it's a WordPress-based PHP simple thing versus our Packet.com website has a bunch of other little bits to it. And frankly, we did that usual thing, which was like just go with the obvious, I won't run into any problems thing. But we actually haven't tried it. We should.
Okay. Good. Heather?
So the main question that everybody asks at all the conferences is, where do I buy an ARM server? So what do I tell them when they ask that? Because, I don't know, they are donated to us, we use Packet. Like if someone wants to go tomorrow and buy a server, where do they go? How do they do that?
Jeff wants to answer that.
Yes. It's an audience panel.
I mean, Packet's one place, right?
Jeff, would you like to introduce yourself? So
sorry.
People on the video
So anybody
kind
that
of
doesn't
know why that question was relevant for you.
Yeah, sorry. So Jeff Underhill, now with Amazon, formerly with ARM. Been driving ARM service for a long time, but no, in half in jest, but in all seriousness, right? Anybody can go to Amazon, spin up an A1 instance. They cost pennies an hour, range from 1 core to 16 cores, up to 32 gig of memory or whatever. Not suitable for every single thing you may want them for. There's reasons you may want a physical server or whatever, but for an awful lot of things, you don't, right? And it's simple, use it. We're starting to see a lot of people using cloud-based ARM instances to augment their physical testing. So think about a company that might have bespoke embedded hardware. They have limited capacity of that hardware, and they really want to use it for full system integration testing. So they will augment that with cloud-based resources to do per pull request continuous integration, and then they'll do nightly builds and test on physical hardware. And that way they can have much better test coverage than they could otherwise.
We're also kind of just at the tipping point of real hardware becoming available. So Calzada, of course, has the Thunder X2.
Actually, Marvell.
That's a memory slip.
We just went way back in time.
Way back in time. Way back in time. Oh, that's embarrassing.
What did you like to?
That's 2 ago. I'm sorry.
Right.
He had no gray hair.
I had hair then.
And I invited them because they're experts. Right. Would you like to try again?
I will try again. Marvell has hardware that is actually available. Ampere has hardware that is available. We're at the point where actual things in boxes that look like real systems are showing up. Even a year ago, we were talking about, you can get an ARM system, but here's a development board, or here's a platform that you can go, and if you put it in a case and you do some work, you might get a system that you could use. Now we're at the point where there's systems that have, in a box, real firmware, behaves the way that you would expect a server to behave, and you can run real workloads on it. And we're just at the beginning of that. I think you'll be seeing more products along that line coming out over the next year.
Right.
But servers never behave themselves.
Well, and I would just clarify a little bit. So you really don't get the server from Marvell, right? So it's our silicon.
Yep.
But
I can explain how I buy servers.
That's right, and you should do that. So, but from our perspective, we're going to enable server vendors. So in fact, today, you can get a system from HP, you can get a system from Cray, you can get a system from Bolt. These are not small systems, so I recognize there's a certain level there, but we also partner with Gigabyte as an ODM. We've got Phoenix as a distributor, and certainly Linaro, ARM, others have utilized that. So there is a representation here across that supply chain that people are used to and have certainly dealt with historically. So more and more of that you're going to continue to see.
As a cloud provider, I can tell you how we bought our first server in 2016 with Caveum before. So Caveum Thunder 1, we actually ended up making it with Foxconn, which is quite a leap for a small company to do. When we just launched our Ampere-based system last week, we literally ordered it from Ampere with their OEM, ODM, Lenovo. So it's evolving.
Right, and to go back to the point that we made, the cloud providers providing ARM natively, Packet, Amazon, etc.
Yeah, it's still not a long laundry list. It's not like your Supermicro catalog, which you all have your Supermicro catalogs, right? If you would like one, every Supermicro salesperson will give you one. So it's not a long list of things you can buy. It's not like you're overrunning with options. But I'm not sure that that's yet really a problem. That's really, like you say, where we're at in the process. Yep. And what we need to do is sustain a certain amount of momentum for a certain amount of time to have those end users beyond hyperscale feel that they can, we're talking enterprises here. How do you get enterprises and even people at development companies and software companies to say, I know where to buy that?
Yeah, I mean, getting to this point, I mean, it's a long road, and getting to this point, there's a lot of engineering work, there's a lot of getting it right, there's a lot of learning, and and there's more to go, but where we are is on the server side, is really, really impressive for the amount of time. And it shows the speed of the ARM ecosystem.
Yeah. Can I share an experience of launching this server last week? So when you launch a new server as a cloud provider, it's not like you literally just plug it in and it always works. I'm sure that's not the same anywhere. And whether you're working with an OEM or an ODM, there's always issues, right? Like firmware is hard, new systems are hard, tick and talk of processors and all the things, integrations. For us, the Lenovo-based system that we launched with Ampere was about the easiest one that we've done in the last maybe 18 months, which includes a variety of AMD and Intel-based systems. And that was just really, I think, because there was a lot of focus between the partners, between Ampere and Lenovo, to get it right. Obviously, that makes a big difference when you're talking about the unboxing experience for any customer.
Right, okay, that's good. You've mainly answered from the point of view of the server, the cloud, the whatever. And, as a very, very, very ex-kernel guy, I wanted to ask Grant about there is a small but very vociferous crowd of guys who are building kernels who want to do that on an ARM-based system. Yeah. What's the story for them?
It's really, really important. It's part of the ecosystem of all this foundational software that all of us depend on. It's going to be of higher quality if the developers who are working on it have very low touch, very low resistance access to the hardware. And the lowest resistance you have is actually your day-to-day machine, where you feel the pain of any individual problem. You feel the pain of individual performance problems or bugs. Having access to that hardware gives a familiarity with the architecture, a familiarity of beyond just what's written in the specs, right? Because if you look at the specifications, you look at things and you see things that look very much that are similar to other architectures. But it's then into the details of, okay, what's the behavior of an ARM-based system? What are the choices that the firmware designers have made? What are the instructions that actually make the most sense when you're working with high-performance SYNLOCs, or how do you optimize those areas? So having access to the systems, even though it's low volume compared to all the other app use cases, is it enables those developers. The other thing that it does, which I don't think gets quite as much attention, is having that low-cost access, and when I say low-cost, I mean low-barrier access to hardware, brings in developers that you wouldn't necessarily get, right? Because it brings in the developers who are that next tier, or who want to work with the hardware, and they've got a problem to solve. If they can do it on the hardware they're going to be running on, they will. But if they can't, you're going to lose them. And so this gives access to a little bit larger than we always assume the developer machines are for.
Okay, thank you. Any question? Good question, though.
Thank you. So within the respective companies you work in and the developer teams that you work with, what is the percentage of people that have an ARM system as their primary workstation today, and where do you want to see that number 1 or 2 years from now?
Okay.
Wow,
do you want
the ball? Go on.
As a primary workstation in my company, I can confidently say it's 0. Yeah.
And where do you want to see it in 2 years?
I mean, our workstations, we don't develop, and we don't do much kernel development. We do some fixing and firmware. I would love to see that in our public cloud, our more of our, to the first question, what are we running on ARM? That's a more natural instinct versus a sort of conscious decision. That would be that would be for us. And I think that's for a lot of our community, which is less in the lower parts of developing the systems architectures and more on simply deploying applications. That would be where I would expect to see the traction. So I don't have a number for you, but that's where I would look.
And so your question is what we're doing internally relative to that?
Yes.
So from our standpoint, we do have the ThunderX2 workstation. It's a high-end workstation, dual socket ThunderX2, and so we've got a lot of our developers and support team with that as a reference platform for them. So, and I'll echo what Grant said in terms of, and we've partnered with ARM for some of the ARM developers to have similar access.
Yep.
There's nothing faster to getting problems solved than seeing it on your desktop, doing the quick spin and addressing it. So, and it's much more efficient from that perspective, and there's sort of edge type cases that otherwise wouldn't be addressed or make the priority cut. But when you're seeing it every day, we've seen that turn around to impact getting things resolved. So I think it's a great example of how that native development aspect can really help.
Yeah. In ARM, I can't say, I wouldn't be able to tell you what the percentages are, but I would categorize it in two areas. And one is the workstation. A bunch of the Thunder X2s are in-house. We've got quite an active program. We want to be running ARM workstations, and there are certain developers who are more keen than others, and so they're the early adopters. But yes, we've got lots of ARM workstations in the company. And then the other is just client machines, right? We do a lot of time working with partners in business communication, which means it means Microsoft Office, it means presentations, it means general desktop business machines. And we've got quite a few who are running the ARM Windows laptops or tablets now. And they have been quite a successful program for running ARM machines.
Okay, good. Good question. Thanks, Art. Another question?
Can I ask you a question?
Yeah, go ahead.
I learned a new word before the panel, which is frippery. Frippery is evidently something that's a little ostentatious in window dressing. Is that right?
Yep.
Yeah. So my question as a marketer is how much of this is, Intel inside, right? How much of this is branding and marketing and positioning? And if so, how do you judge that?
That's a good question. Well, I'm not.
Does it matter to the outside world, or does it just matter for the results, right? Like, are we just looking at ARM on ARM improves efficiency of developers, we make a better product, or how much of it is a positioning statement that you want to go and tell that story?
Well, I'm not a marketing person, but I would say part of it is the architecture coming of age. It's coming from an embedded and mobile world. It's the recipient of lots of software. It is in itself the ARM architecture. I only do architectures that begin with A, right? So it's a lovely architecture, and it deserves to be everywhere. Getting from being that embedded thing or the mobile thing to the compute power of the planet is growing kind of exponentially, and it's growing mainly in the data center and even more. Well, can you grow even more exponentially? Anyway,
I don't know.
On the embedded side, it's going exponential too.
Yeah.
And yes, the portable device such as my Chromebook, which I've got here, that's all very necessary. But it's part of for me, it's part of the architecture maturing and being able to use it everywhere.
Yeah.
But that's, as I said, it's a long road, and a lot needs to happen.
Yeah. I'm not sure you can separate the two, in that there's certainly that confidence of being out in public saying ARM works everywhere.
Right.
But there's also the confidence of we believe enough in this that we're sitting down in front of our desks with ARM machines, and we use it day to day. It's not merely the marketing message, but the fact that we're doing that is an excellent marketing message.
It's an excellent marketing message.
And I think with all of this, you can always create noise, which is marketing. And there would be nothing
frippery.
It would be frivolous marketing of a frippery nature, and it would create a whole bunch of nothing and a lot of disappointment. So I think the way that this has generally worked is it's just the ARM ecosystem has very quietly got on and done a lot of work. I've known Larry, I've had the privilege of knowing Larry for a long time now through Linaro and my association with him. And I've seen how he and the company have just consistently worked at this engineering problem better and better, making the relationships, making all the bits of software work together, and that's awesome progress. And I really don't want to see it overhyped and marketed. It's just something that good engineering generates.
I know the reaction well that you speak of, because I live in a company of engineers, and marketing is sometimes a bad word, right? It sort of misses the point.
Despite the fact that we are sat here kind of doing a little bit of marketing.
Yeah.
But talking as an engineer.
I would just phrase it in the sort of consumerization of everything that we're doing, and packaging the message sort of can matter. So,
Right.
anyways,
But
Okay.
from a marketing standpoint, you do have to compete
Yeah.
to get
Yes,
the
of course you do.
attention.
Yeah.
But I think the other aspect of that question is timing in the industry in terms of where we are right now.
sure.
There is a level of diversity and competition that is beyond ARM. If you think about AMD's coming back in the server space, accelerators, offloads,
Yep.
Yes.
some of that, it's actually a pretty exciting time compared to where we were not that long ago, where
Well, yeah.
it was pretty monochromatic. And so that timing plays well, but that forces you then to have to elevate your message.
Yeah, and
Yeah,
to speak to that, I believe that the ARM ecosystem, the IP business model, is a fundamental engine for change and an acceleration in an evolutionary way. So, and I'm passionate about exactly that.
Yeah.
That together with open source opens up markets and generates change, and a change that the rate of change is changing rapidly. That's not a very good sentence. You might need to put some marketing gloss on it, but I think it's a really good thing. Anyway, I can see another question, so let's take another question.
So, following on slightly from the last question, is it time to maybe ease back on the marketing and start on the delivering?
Well,
Any specific examples?
Are we not delivering? I thought we were going to.
let me
Steve, they're
expand
not
on that.
mutually exclusive.
Sure.
You can do both at
Yeah,
the
yeah.
same time. And they're
Yeah.
totally
So-
different people. It's not
Well,
like
yeah,
you've got
where I'm coming from is, so for a number of years, I've been absolutely a believer. I've got a load of ARM systems at home. You know, I've got a Macchiato on my desk. I've got a Synquaso. I've got, lots of cool machines. I still have friends and colleagues scattered in various open source projects who are asking me, so when can I buy the $500 desktop? When can I buy the $1,000 server? Which won't have the frictions. So it'll have PCI that works. It'll take standard components where it's not going to need the, it all works.
If you do this.
That's the thing. We keep on getting incrementally closer.
Yeah.
When do we think we're going to be there?
Yeah, the question is from the very upstanding member of the Debian community, Steve, there. And I feel the same. I am passionate about ARM. I've been doing ARM since the strong ARM days, you know my history. And I really believe in it, want it to happen. So, yes, it's a long road. Grant.
We're close. I mean, it's become far more of a priority recently. It's no longer sufficient, or it's no longer even an acceptable option to say, there's this nice dev board over there. There's this nice board you can buy. No, we need desktop systems. We need a range of desktop systems, but from the small $500 device all the way up to high-end workstations. There are real devices out there that can be purchased now. On the clamshell, on the laptop side, there's the ARM notebooks, and those are real platforms. They have real industrial design around them. They work. They've got real firmware. That's one of the options. There is active discussion. I can't announce anything or say anything about what's actually coming, but it's soon.
We were talking about that this morning after the ARM on ARM design based on the 96 board, and we were wondering if maybe the best way to enable the board student to touch an ARM system wouldn't be for Apple to make a MacBook Pro based on ARM.
But I think just to build on this a little bit, we are there at the server, in the server world right now. And I talked about this morning. We've got deployments in some of the most demanding high-end computing environments in Europe, in the US, certainly from our perspective. We're in the top 500 supercomputer. You look at the devices that are hanging off of that. But what it takes to be successful in the server space is that entire supply chain working together. From a Linaro perspective, we're really focused on a lot of the open source software components. But to get all those components working, typically you're going to be working with a tier 1 OEM, where now you're bringing in full chassis, high-end I/O, in our case like Mellanox and InfiniBand, all of those pieces that have to come together, and you're seeing that and deploying at scale now. So it is a matter of not just what we do within the umbrella of Linaro, but it goes beyond that. But you are seeing many instances and many examples of that today.
Yeah, okay. Like, I was going to say that the thing that impressed me about you through the years as you've been pushing towards this is that really what you've done is built up trust relationships.
Right.
You're supplying people with all the pieces, and it all works together so that, you know, gentleman on the end plugs it in and has the best install experience, you know, in 18 months. Mm-hmm. Quick question, is there anything the desktop boys, could learn from your experiences? Are there any hints you could give them to do this faster than you guys could?
Tenacity and forget some of the challenges.
Yeah, okay.
I think you have to take a system perspective, right? Just speaking, in our case, we own the silicon. We don't own that system part, so it takes the system partners to really drive through that. So whatever space you're targeting, you're going to make sure that end to end you're addressing that piece. And one of the things we do is we build a reference platform. That's really more for our consumption and our partners, not necessarily the end product, but that shakes out a lot of those problems, and we've benefited from that.
Yeah.
Okay, thanks. We've got a question at the back.
So one of the things that's often the case in the server systems is that the servers are AArch64 only, and quite often if we're talking about developing ARM on ARM, so you can test on these things, is that we often want to test on AArch32 as well. Is there a danger that we're leaving AArch32 to the dev boards?
Right. Is poor old AArch32 being left behind?
Poor old AArch32. AArch32 still has an awful lot of places where it's being deployed. A lot of the focus on architecture, because with the general purpose systems, there's the whole firmware stack, there's all the work that goes into tiering the ecosystem so that you can have silicon vendors and hardware vendors and firmware vendors and OS vendors and applications all working well together. And all of that focus is 64-bit, right? That is the platform. That's where we put the focus. When we're talking IoT, when we're talking edge, when we're talking embedded, there's an awful lot of 32-bit products, and there's going to be for a very long time. The drivers in that market, depending on where you look, are different. Some parts of it actually look an awful lot like AArch64, and so for example, in Ledge, where we're looking at edge computing, we're looking at what is needed on those platforms, we're very much looking at firmware architecture, we're very much looking at what's required on the OS, and we're certainly looking at both 64-bit and 32-bit. So it's really important there, and we're paying attention to the 32-bit story for that. We're not going to see any servers in that space that are 32-bit, but we want to use all that same ecosystem. So we're talking about UEFI, we're talking about secure boot, we're talking about those things on the edge when you're talking about provisioning them behaving in the same way that you would expect. On the smaller embedded systems, it's probably not going to look quite the same. And in fact, that part of the market, 32-bit embedded, the way that it's been working, there's quite a healthy ecosystem there already. But it's a different ecosystem from the general purpose server, desktop, high-end or higher-end edge device market that we would be talking about here.
Can I add to that?
Sure, please do.
And I love you raising your hand. Do you want to add right now?
Yeah, I just wanted to add to that the issue there is that there is a lot of AArch32 hardware out there, but not all of that or most of that hardware is not actually useful for really, building software on. So what would actually be needed is like 32-bit compatible servers that are actually usable with large RAM configurations in order to build natively for AArch32.
I was going to actually add in that almost half of the initial inventory that we deployed last week with Ampere was sold to a single customer who needs what? 32-bit, because Ampere actually still does 32-bit. Before that, it was high silicon, right? Which we have people building for IoT, building for different use cases. There's a huge demand for actual ARM servers that can complete a build in the timeline that their pipeline requires it, which is somewhere less than an hour. And so that's a huge demand right now for actual powerful ARM servers in the data center is 32-bit software development.
Just wanted to add to that. It also helps with the developer productivity. The number of people who work on foundational system software like tool chains and things like that need fast machines.
Yeah.
The number of people who are doing that are a small group of people. So having a fast ARch32 machine is extremely useful for us to maintain, for example, GCC or the GNU toolchain, which is what I work on, effectively and efficiently, so that we can be effective and efficient in what we do with maintaining ARch32 and improving ARch32, as well as working on ARch64. So it does help.
That's a really good point.
Yeah.
Did you wish to add something, Jeff? Jacob?
It's actually the same thing for kernel developers. We also really like to run virtual machines with our kernels and run 32-bit kernels on nice, fast hardware instead of using QEMU.
I've got lots of it, if you'd like some. It really is, I think... Okay, come on, yeah, in the desk. Well, that's even better, right? But it sort of speaks to where is software being built and developed, and where you know, obviously there's a convenience factor we're talking about this morning all day about ARM on ARM. Yeah. But if you reach outside of that community even further, it's often being built in a cloud environment, and you start to deal with some of the issues there, which are opportunities as well.
Well, there's a huge shift in where and how software is developed. Right? I mean, it's astonishing. I mean, my narrow kind of kernel background is done on my lap, but it's actually mostly done.
It's still very important. It's just a more nuanced conversation now, for sure.
Yeah, exactly.
And we're seeing, just for context, we're seeing, so there's really this sort of your background coming up and starting to, you know, I mean, this is obviously the trajectory of your career.
Get off my lawn.
There's just an enormous number of developers who are actually coming down, who learned to develop and have never done anything else besides firing up an EC2 instance. That is how they start.
Yeah.
And then they come down further and ask for more things.
Okay, that's good. Another question, if there is one. No? Thank you. What a great audience. They're asking questions.
It's amazing.
Well, sensible questions would be nice as well. That's good.
So, a platform in the cloud provides that low barrier for developing ARM on ARM. But it is not very well suitable for developing fundamental software like firmware.
Right. Yeah, that's a good differentiation.
Yes. So, and you know, I don't want to spend that $500 bringing a desktop onto my desk.
Yeah.
So what does it take to make that cloud platform friendly for developing fundamental software? Is it even possible?
So your question is, what makes it possible for you to do kernel development in the cloud?
Is it possible? Let's say I want to develop...
I'm not a kernel developer, but we seem to have plenty of kernel. I mean, not just on ARM. I mean, obviously we have, you know, people from the Linux kernel through the Linux Foundation, and you know, working with Red Hat and others to do kernel development and pipelining. Obviously, you need usually bare metal, I would say, which I think is an important differentiation. And we, of course, have a vested interest in defining cloud not as a virtualization experience, but an automation experience. And you see that even in Jeff. We're looking forward to your bare metal ARM offering, yeah? But bare metal in x86 is an option now at Amazon. And so I think that is maybe just a shift in sort of what's the cloud. But if you're simply getting a bare metal server, I think kernel development, again, not a kernel developer, is totally viable.
Yep. Question? Oops.
Maybe to simply explain that to you then, like, you know, as a kernel developer, we will have like local code on the machine that, you know, we're sitting in front of that is not yet fully ready and that we may want to, like, you know, compile test or even do functional tests with. And what you're proposing is, you know, you can have a second machine that's somewhere located in the cloud, but the difference is, like, you know, how do we get this unfinished data into the cloud in order to get it tested? And I don't think that there is an easy solution that anyone is providing, neither Packet nor Amazon for that.
Yeah, and there is a kind of thrill of building the kernel on the machine and rebooting the machine to use the kernel, and wondering if it ever will come back to you or burst into flames.
It will often burst into flames.
I'm actually going to disagree with that a little bit.
I mean, you can just push your code to GitHub or something, and then fetch again on the virtual machine. But that's not always
We've
the right
come
thing.
up with all kinds of ways of getting code out to where we want to run it, and mostly it's from necessity, from not having that machine in front of us. It's still not the most efficient. There's still the case where wanting to have the machine on your desk in front of you, direct access. There's times that we want to do that, but also having the machine, access to the machine when I don't have have it directly in front of me. We're good at pushing code out to machines. We do it out to when we were cross-compiling, we were doing that all the time to push it out to a machine. That may also happen to be on our desk, but it's not significantly different. Pushing out to GitHub integrated with a CI loop that creates your artifacts, which is your kernel, and then squirting that out to
you certainly have to have
VM
tools to deal with when that exact thing happens.
Yeah, exactly.
Which I mean, custom kernels are very important for a lot of companies, and having the ability to recover from the disaster is really important. But I think that's a commitment to how do we enable developers to develop further down the stack. Just in general, because that's not simply the ecosystem. That's also people who are optimizing their own kernels and doing it for other reasons.
And I think that this is part of what's in cloud development, and the move to cloud development, and the move to a lot more emphasis on CI, and CI becoming more accessible has had a massive impact on development, right? Where the level of rigor of the testing and of the things that we're able to do is considerably better. It's a lot more accessible than it used to be. We don't have to set up our own CI instance.
All the improvements in being, that container stuff, being able to install, roll it back, recreate it. I mean, it's just awesome in terms of a proper development plan.
Yeah. So I think that we're seeing there's the cloud development isn't a shift, get away from the desk and go do everything in the cloud, but the cloud is actually bringing a whole bunch more capability and a whole bunch more functionality and the ability to do our jobs in another way, in addition to having the box on our desk, which is still really important, right? It's not to say don't do development on your desk, but you now have a lot more options for how to do the kernel work that needs to be done.
Yeah, I mean, and over the last little while, I mean, the improvements in things like Docker containers on the ARM architecture are just awesome to be able to sit there and do it. And one of the things you get by running your development machine as an ARM machine is you notice when it doesn't work, and so you fix it.
You fix it.
So there's some
I think that's a really,
effects
I think that's a really important thing. Ed on my team was reminding me, like, the importance of having something on your desk, obviously, for ease of use and reduce friction, but it also, you have to look at it and go, what should I fix today? What should I try today? It's sort of an instantiation of that ambition right there, which is kind of, tips you a little further.
Okay, that's a really good point. Another question. We're getting towards the end. I'm willing to take a question or two. That's all right. You're very welcome.
Yeah, so we seem to have this gap between the low-end machines, like the Macchiato bin with Marvell Armada chip, and the Chromebooks and whatnot, that are basically too slow to do anything useful, and the high-end that is too expensive, but they're very nice machines, like the Thunder X2. Yes. I think the only thing that will solve the problem is if we get some mass market product with the right core count at the right price. But what would be that mass market that would have to be there first before we can get those chips cheap enough to put them into lots of boxes?
I know they're the panel, and I'm supposed to ask questions, they're supposed to answer them. I'm going to reverse that slightly. I'm a big fan of Chromebooks, right? I really like the fact that I can run Android apps, I like the browser. But what I really, really, really like is the Linux thing on them, which is super. So I can sit there, I can have a basic Linux environment, I can build stuff, I can do stuff, and then I can run it somewhere else, and that's, I mean, it's a kind of halfway house for me, but and I don't do really heavy kernel work, building lots and lots of things, but it's good enough that I've got a native environment that's ARM64.
You were asking for the magic number? The mass market?
What's the mass market device?
What's the incentive today for somebody to buy an ARM machine to develop, right? I mean, outside of this group here, right?
Yeah, well, I mean, I mean, again, how do you encourage adoption? You can do it by making the most compelling product that everyone just has to have. you can change pricing and subsidies. You can compel things to happen. Mass market
Now,
is...
what would be the driving market? What would be the product that would get Marvell to produce a 12 or 16 core version of the Thunder X2 and make it in a form factor that can be produced cheaply enough that there will be products, something that can be turned into a developer workstation?
What's the previous example, maybe, too?
Well, and just, from our perspective, it is a little bit of a chicken and egg, right? Because to get down to the price point you're talking about, you've got to have the volume. And so when do you get the volume to the price point? So this is an interesting squeeze. Certainly from a market standpoint for what we're doing, Thunder X2, we've definitely gone more on a higher end performance side. So does it fit a high-end workstation type use case and demand? Absolutely. Would the price would come down with more demand? Absolutely. Will that happen over time? I think it probably will, but a lower end kind of device is not necessarily where we're going to focus for that part of the Marvell product line. It's just where we're going to target and focus from our business.
So your hope would be that the current technology would become cheap enough for everybody, not that you would make something not as good that would already automatically be cheaper.
Well, I think but it's not just the silicon part of this, it's also the system partner.
Yeah.
Right, so as a Gigabyte as a system partner, they're gonna, they've got to manage their supply and their cost structure based on volume they're seeing. So that's the magic point here. Okay. And are there optimizations you can do at the system level in terms of bringing down cost or targeting? Can you go to a single socket? I mean, there's a lot of things you can move on, and our partners are certainly willing to make those investments if they can see the path to revenue and to optimization.
That's why I was asking about what market would be needed to drive those millions of chips that would get you to produce those.
Yeah. It's difficult to speculate on what that market would be in an open forum that's being recorded on the internet right here. When we're talking about business relationships, it is an active conversation, though, right? Yeah. There are people in ARM. There are people in our partners who are actively talking about this, of recognizing these developer systems, these accessible systems are important. Right. We need them. How are we going to do it?
But I'll just add one point. It's interesting how at least the discussion has evolved. And right, if you had sat here 12, 18 months ago, it would be, give me something. Yeah. Right? Now we've got something. Give me something faster. I got something faster. Now bring the price down. Yeah. This is a great discussion to have because that's a natural evolution. Yeah. So we've come a long way. We're not done. Yeah. But it's nice to see that we're having that evolution.
Yeah. And there's excitement in what NVIDIA's doing and their mass market.
I mean, there's a great deal of
you can't even buy it.
Hold the thought. Just
Dave wants us to stop talking.
Yeah, so I'm trying to get control back. That's what
Good luck.
It's all about me. It's not about you. Yeah. And I'm going to hold it there. And there's some good conversation can happen involving beer later, so you will get there. I think this is everyone in the supply chain has to make money, right? I mean, in the end, I think a lot of this is now not really about engineering. I think the pieces are kind of there. I think this is about bringing ecosystems and supply lines, and as Arne puts it, there being the demand for something. Anyway, good conversation. Thank you very much. Last word from each of you, please.
Last word.
Go on, Larry. You can't. I've got him.
Well, I'll echo a little bit of what I talked about this morning, but the reason, at least from a Marvell perspective, that we're able to now drive out full solutions at a high-end commercial ISV is because of the investment from this community over time, right? Yep. Because my worry, I don't cringe now when somebody like Jacob pulls out one of our boxes out of packaging and worry if it's going to work or not. It's going to work, right? Now it's about how do we optimize, how do we improve performance, how do we add solutions. That's a much more interesting and motivating area to be in. We wouldn't have gotten there without the help from this community and this group. So we're not done, but it's been tremendous to see that progress and be able to build on top of that.
I'm sorry, Jacob.
Sure, yeah, well, I would love, there were some things I don't know about here on the developer workflow which we live in a cloud-centric world ourselves at Packet. I'd love to hear what else, what's the ideal, even if it's not attainable on our own. I would love to support that, and that's the kind of thing where even on our team, we're trying to think about how do we make hardware, for developers, which is a crazy thing to do, but it is a wonderful thing to do if it makes sense, and we'd love to help. So feedback would be fantastic.
Okay, thanks. And you'll get feedback from these guys.
Sounds like it.
So, Grant, last word.
And I want to echo what Larry was saying, that, I mean, it's been a lot of work. I remember when we first started this, and it was recognizing it's like, this is going to take a lot of years. And it did. And now we're here, and things are real. It's been a lot of hard work, but now I think we've kind of hit that point of that positive feedback loop of all the work to standardize things, to make things boring for Mr. Masters, to get to get this to an ecosystem. We're starting to see the effects of that, of things that are going on in Edge is being affected by what's happened in server, things that are going on in computer. We're having conversations across the platform that I think we're just at the beginning of things really getting rolling.
Yeah, I mean, I've been at this, Linaro I've been at 9 years now, which I can't believe, and strong ARM forever. Some of you were probably not born when I first started playing with the ARM architecture. So anyway, it has been really delightful. I've enjoyed myself thoroughly. I have no idea how good or bad or indifferent the video is, but thank you very much, gentlemen.
Pleasure.
Thank you. Audience.